Alright, the Charles law talks about the temperature and the volume of an area or substance. So let's say the temperature is measured in Kelvin, which is represented by a big K, and the volume is measured in liters. Usually, this is usual measurements. The measurements can definitely change. And the Charles law says that the temperature increases in an area, the volume would increase. Well, if you think about that, it does make sense, because once you have hotter particles, once you heat something up, let's say the temperature is higher. Once you heat something up, these dots are just represented as particles. They want to move more, and as they move more, they would expand. The gas would move away from each other, and they'd slowly try to expand. Alright, so I'll give you a better example down here. Let's say these two things right here, they're burners. Maybe not the best, but I tried. Right here, we say we have a can right here, a can of some spray, a spray bottle can, and right here on the left one are represented by blue, the temperature is not high, and the right one are represented by red, the temperature is high. Alright, so in the red one, the particles or molecules inside it are trying to expand, and in the other one, the one that's not on, the particles are just moving around calmly, and they're not heated up yet, so they're not moving as fast and as powerful. So on this one right here, the particles are trying to expand. So in the bottle, they're all trying to point away out of the bottle, trying to get out of the bottle. And once that happens, if you heat up a spray bottle, which I do not suggest, it would explode. After a while of putting on high heat, it would explode. Alright, so introducing you to the Charles law. The Charles law formula says that the volume of the first substance divided by the temperature of the first substance is equal to the volume of the second over the temperature of the second. So let's say if you were isolating and trying to figure out T2, the temperature of the second, what I would suggest is doing some basic algebra. You would cross multiply, and then you would have V1 times T2, and then you would have T1 times V2, and then you slowly simplify and do a one-step equation, as I would say, and solve for T2, which you are looking for. Alright, so instead of doing it like this, I have an actual example, and I will move on to that right now. Equal to V2 over T2. Right here, we do not have V2, so V2 is the unknown. So let's write down what we know so far. So we know V1. V1 is 9.714 over T1, which is 625.536, 625.53. And that's going to equal to V2, which is, we don't know, I'll represent that by X variable, over T2, which is 947.33, 947.33. Alright, so let me switch a color here. What I would do right here is cross multiply, as I said. Put arrows to signify what we're multiplying by. When you cross multiply, you are, no pun intended, you're literally multiplying. So you would have to multiply 9.714 by the one that is crossed, which is 947.33. In fact, I'll actually multiply 625.53. I'll believe that's correct. 625.53 times x, which you just put an x variable there, and you would multiply that by 9.714 times. I'll put this right here in the calculator. 9.714 times 947.33, which will give you 9,202.36. 9,202.36. Oh, I didn't mean to put a comma. 0.36. Let's put 0.36. Alright, so now what you do a simple one-step equation. You just divide both sides by what is attached to the variable. So right here, what's attached to the variable is 625.53. And right here, that will cancel, and you divide this side by 625.53. So now we know what x is going to be alone. X is simply 9,202.36 divided by 625.53. So x is equal to approximately, let me get the calculator again, 9,202.36 divided by 625.53. That will give you 14.71. 14.71. And as this is the V2, this first volume, and the volume of the other substance liters, you would put this in liters also. Do not forget the measurement, as it is a measurement. It is literally a measurement that you're looking for. Alright, so what do we learn in this video? What we learned is basically that the Charles law says that as the temperature increases of a area or substance, the volume would increase as hot particles move more fast and they are a lot stronger. And yet the formula of Charles' law is V1 over T1 is equal to V2 over T2. Alright, thanks for watching.